Good morning, class. The session is being recorded. Therefore, if there is any privacy issue, you want to pay attention to that. I would ask you to mute your audio video, as always. In fact, you can even change your name to your initials. Don't put anything in the chat. If there's any privacy issue, remember we are recording and we are posting it for you and your fellow students. When I ask you to participate, it is absolutely up to you. Please do not participate if there is any privacy issue. At the end, I will ask you to put your full name, last comma first in the chat as part of the roll sheet and attendance, of course, at the end when we stop the recording. All right, so we are looking at section 3.4, the product and the quotient rule. We covered a few sections, derivatives and rates of change, derivatives as a function, basic differentiation formulas, and now we are moving towards the product and quotient rules. So let's quickly recap what we have done. Well, we started with the good old slope, which is defined as rise over run, okay? The average rate of y with respect to x. So depending on how we write this, if you look at this one, this is a plus h. If you go with that format, p and q gives rise to this formula in the middle, f of a plus h minus f of a over h. If I use x here, it gives us the first equation. If I use b here, it gives us the third equation. It makes no difference. All of them are simply the slope of this blue line, which is called the secant line. It's connecting 2 points on the curve. And this is just a simple old, slope everybody is familiar with. And of course, all of them really in essence are the difference quotient. More specifically, this one is the one that is used as the difference quotient. What happens if we move this q and get it closer and closer to this point P, it gives rise to the line known as a tangent line. And in order to come up with the equation of a tangent line, we need a pair, we have it, and we need the slope. The slope of a tangent line is the limit of the slope of the secant line as q approaches P, or depends upon whether we use this format or this format. In this case, x approaches a, in this case, h approaches 0. And we call this f prime of a, which is the slope of a tangent line at x equals a. There are two different ways of writing it. And whether we use this one, it becomes the limit of f of x minus f of a over x minus a as x approaches a. Or if we use this one, becomes the limit of f of a plus h minus f of a over h as h approaches 0. Finally, this gives us the equation of a tangent line. As I mentioned, you don't have to memorize it in this format. It's just the point slope. So I'm going to repeat that. Okay, y minus y1 is m times x minus x1. So it's something you've seen. There's nothing brand new here. Okay, everybody? And so I hope everybody is comfortable with that. And of course, the equation that you see here, this is the differentiation in general. dy dx, the Leibniz notation, the limit of delta y over delta x as delta x approaches 0, or simply f prime of x is the limit of f of x plus h minus f of x over h as h approaches 0. Okay, so what we want to do, we want to go to the new section. And before I do that, I'm going to stop the video in case. Okay, sometimes things get blurry when I have the video on. Please let me know if that happens so we can slow down. So for the sake of not having a problem with the screen, I turned it off. So again, let's quickly recap what we have. The Leibniz notation, dy dx, limit of delta y over delta x as delta x approaches 0, and the definition of a differentiation. We looked at The derivative of x is 1. If you have a constant, you can take it out. If you're adding or subtracting, you can do them term by term. The derivative of a constant is 0, any number. This is your power rule. Okay, basically, the exponent sits in front, and we subtract 1 from the exponent. The exponential format, e to the power of x, the derivative is itself. Then we go to trigonometric functions. We don't spend too much time on trigonometric functions in this course, but we come across a few of it. The derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of tangent is secant squared. Cotangent gives us negative cosecant squared. Secant gives us secant x tan x. Cosecant results in negative cosecant x cotangent x. And again, with a little bit of a practice, you all become very comfortable with this. Nothing to worry about. What we want to go over now is the synopsis of what I call a product and quotient rule. And the formula is as such: if you are dealing with two functions, you're multiplying them. In order to differentiate that, you can differentiate one of them times the other, plus differentiate the other one times the first. For example, f of x times g of x. The derivative of f of x is f prime times g of x, plus the derivative of g is g prime times f of x. The reason I like this notation, it helps me memorize the formula for the quotient rule, which basically uses almost the same thing in the numerator. It changes the plus to negative and the denominator over g of x. Okay, so g squared in essence. So take a look at the shorthand notation. I like the shorthand notation because it helps me memorize this class. F g prime is f prime g plus g prime f. And I use the same thing in the numerator. I change the positive to negative. Now, we prove this, and we go over the proof of both in regular calculus course. In this course, we don't. I have the proof for you in the PowerPoint that I posted in the beach board. And so please take a look at that. You're more than welcome to stop by during my office hours, and I will gladly go over that for you if you like. So a quick recap of what we did. That was the synopsis of the section. If by analogy with the sum and difference, one may be under the assumption that the derivative of a product is the product of the derivatives. But that's not how it works here. We are going to show that with a very simple example. That's not how it's going to work. By the way, the formula that you see here, this is the format that you find it in most text. If you have seen it, if you have memorized it already in this fashion, please stick with that. I'm not asking you to go with the shorthand notation I put up for you. I think it's helpful if you're learning it for the first time. I think that may not be a bad idea to stick with what I went over. But anyways, let's start with these two very simple examples. If f of x is x, then we know by the power rule f prime is simply 1. If g of x is x squared, we know g prime is 2x, right? So we know that it's very simple. Now, if we are going with this notion that the derivative of a product is the product of the derivatives, that means if we are looking at the 2, we multiply the 2, we get to x cubed. According to this, the derivative must be 1 times 2x, which is equal to 2x, and we know that's not the case. How do we know that? Very simple. When we multiply these two class, we get x cubed. And by the power rule, the answer is 3x squared, which is not equal to, okay, so this is not equal to f prime times g prime. So this doesn't work. So what does it work? Let's stick with the shorthand notation I gave you. F prime times g, okay? So f prime times g. Let's multiply these two. What is f prime times g? X squared plus g prime times f, 2x times x. And I hope you realize they do add up to 3x squared. So this is a simple example to illustrate the fact that fg prime equals f prime g plus g prime f. So it does work. What I'd like you to do is to do this, of course, at home, find the derivative both ways. Can anybody tell me what I mean by both ways? What would be the first way? The method of the previous section, which means you do what? You do the foiling, you multiply the two, and then you use the method of the previous section using the power rule. What is the second method? The method of this section. The product rule. Okay, so you could do that. Bear in mind, this is easy to do. In some instances, it's not doable, okay? And therefore, we stick with the product rule. All right. We are going to use the product rule to differentiate this. And notice what I'm asking you. I don't want you to simplify. And the reason is very simple. I want to emphasize the importance of the calculus step on a normal basis. And I've mentioned that many times. On a normal basis, we don't have many calculus steps. So let's see how this thing works. Okay. So we have a couple of parentheses. The first one, I'm going to call it the f function. The second one, I'm going to call it the g function. So we are looking at f times g. Therefore, we are going to go with the product rule. Okay. Let's see what the product rule tells us. The product rule tells us f prime g. So what is f prime, everybody? F prime is 4x cubed minus 2 times 3x squared minus 6x. By 6x squared, we've done this many times by now. And minus 7 results in 0. So this is f prime. Okay, times g. So just write this, times g. Times g. Plus g prime. So we are going to differentiate the second part, g. Gives us what? 6x minus 5. So plus 6x minus 5. And then just times f. Just write the first piece. Just write it. And believe it or not, this is the end of the calculus part. You're done. What do you do next? And we're not going to do it. I highly recommend you do it at home, by the way, is to just multiply these two, add up like terms. I like to put the answer in descending order. You don't have to if you're not asked. But I hope you realize we have several steps left, all of which are algebraic steps. And that's why I keep on emphasizing on this concept. Calculus, believe it or not, is not difficult as long as the prior knowledge of mathematics is there. And that's why you really want to attend your SA sessions in case, you want to practice certain stuff from algebra. All right, let's look at this example. F of x is given as x e to the power of x. What I like to do is to first and foremost put a raised dot in between, meaning I'm dealing with a product rule. And in fact, I'm going to call this f times g, which means I'm saying the f function is the x function and the g is e to the power of x. Okay. And so with that being the case, what do? Well, we go back to the good old formula for the product rule. F is x, the derivative of that f prime becomes 1 times e to the power of x, plus g prime f. What is the derivative of e to the power of x? It's itself times x. Done with calculus. So what comes next? We're going to factor out e to the power of x. When we factor e to the power of x, this one gives us 1, this one gives us x. Whether you write that e to the power of x times 1 plus x, and I like to follow the order that it's given, or change it to e to the power of x, e to the power of x times x plus 1. Makes no difference. The second part B, f double prime of x, is asking us to differentiate this one again. So let me do this again and write this as e to the power of x times 1 plus x. I'm going to call this one the f function, this one the g function. Again, not that you have to do that in the beginning. If it helps, I would highly recommend you stick with the methodology I'm using. Call this the f function, call this the g function, and now stick with the formula. Which means now we are going to go f prime e to the power of x, the derivative is itself, times g times the parentheses, plus g prime. The derivative of the parentheses is just 1 times f times e to the power of x. And that, so I'm going to quickly repeat. Let me just put it at top, in fact. So I'm looking at f prime g plus g prime f. Done with calculus, we are going to rewrite this by factoring it as follows. If I factor the e to the power of x out, this gives me x plus 1, and this gives me plus 1. And obviously 1 and 1, they add up to 2. And that's my final answer. Again, one simple step of calculus, several steps of algebra. Product rule. All right. Here's the next one, everybody. Y is equal to x squared times sine x. I'm going to put a raised dot in between. Meaning I am dealing with the product rule. And I'm going to call this f and this one g. F of x times g of x. And we're going to stick with the product rule. We're going to stick with the product rule. Okay. X squared. I need to differentiate that to get to f prime. That gives me 2x. So f prime times g times sine x. F prime times g plus g prime times f. I need to differentiate this g, which is sine x. That gives me cosine x times x squared. So let's again write this just to make sure we are in good shape. So we have f prime g plus g prime f. We are done. It's really a good practice to put x squared in front. So we are going to write 2x sine x plus x squared cosine x. This is the proper way of writing this. And as you can see, we have used the product rule on all of this. Okay, fairly nice and easy. So all we are doing, we are practicing, we are drilling class, practicing. That's all it takes to master the beauty of mathematics. We're going to look at a quotient rule. And again, I'm asking you to just differentiate, do not simplify. Again, for the sake of illustration as to how this thing works. Okay, everybody? By the way, I'm using the same f and g. And if you recall, when we did the warm-up example for the product rule, I had f times g, same f, same g. Now we have f over g, and I'm going to use this. And again, I'm going to remind you that for fg prime, we have f prime g plus g prime f. So because we have, I hope we have memorized it by now. Because we have memorized this, then memorization of the quotient rule is just as easy. I just change this to a negative sign. See, I repeat the same thing and I change the sign. That's why I like this shorthand notation. It really helps me, okay? Remember the formula. And of course, the denominator, you just write the denominator. Don't do anything. You put it in a parenthesis and square it, okay? The only thing that happens eventually at the end, if you can, you simplify. If you cannot, you're done. And that's the end of the story. So let's go with the formula. The formula says f prime g. So let's stick with f prime. If this is the f, we've done the f prime before, so let's repeat that. So this gives us 4x cubed minus 2 times 3x squared or minus 6x squared. So that's f prime, everybody. So f prime. So we want y prime equals, here's f prime, times g. I'm going to just write the g, times g. Just write the g. Don't do anything. Just write it. That's all. Minus, now g prime. So we're going to differentiate this. Gives us 6x minus 5. 6x minus 5. And then write the f times f. Just write the f. So g prime, everybody, minus g prime. And now I'm going to tag along f. That's all. I'm going to write f. So what is my denominator? G squared. Just g squared. That means write this. That's all. Put it in a parentheses. Okay, I want g squared. Put it in a parentheses and square it. And believe it or not, you're done with the calculus step. So I hope you see how this is done. Again, needless to say, this is not finished class. You have to multiply these two. You have to multiply these two. Never mind, don't forget the negative sign, combine like terms, and I like to put them in descending order. Put them in descending order for the sake of factoring, see if anything happens. So there are several algebraic steps left, without a doubt. However, I think it's fairly obvious what happens with the first step, which is a calculus step. As long as we can handle this, we can handle the rest of it. And by the way, as always, when it comes to grading, the most important part of the grade goes for the calculus step. All right. Let's differentiate this one. So we're going to call this the f function, x squared minus 3x. We're going to call this the g function, x minus 1. And anytime you have a rational expression class, your very first step is to simplify if you can. That means, is there a common factor between the numerator and the denominator? If I factor the numerator, nothing changes, nothing simplifies. Again, because of that, you don't have to factor it. And in fact, for the sake of differentiation, the factored form makes it more difficult. You don't want to factor it, but perhaps you want to factor it in your head to see if there is a common factor between the top and the bottom. And if there is, simplify it and then move on. That's the first step. We are going to use the quotient rule. So we have, so y prime equals a big fraction bar f prime g. So f prime, what is the derivative of the top? The top gives us 2x minus 3 times g. Just repeat the denominator, times x minus 1. Minus g prime, the derivative of the bottom is simply 1 times the top, okay, f. And then what do? Just write this one, don't make any changes, put it in a parentheses and square it. So what do we have now? F prime g minus g prime f over g squared. Done with calculus. We are going to use our algebraic techniques to simplify this, everybody. We are going to simplify this. So let us do that. We are going to FOIL the top. This one, if you multiply, you get 2x squared minus 2x, right? I'm distributing 2x minus 3x positive 3 and this to add up to negative 5x. I'm going to distribute the negative 1. Everything changes sign inside the parentheses, minus x squared plus 3x. So that's what you have. So minus 5x and 3x, they combine into negative 2x, 2x squared, and minus x squared, they combine into x squared, and you just have a constant of 3. Now, this is the answer we get, and it is important again to remember anytime we have a rational expression, can we simplify it further? Is there a common factor between the top and the bottom? Okay. If you don't recognize it, you have to see if there is any way to factor it. One of the things that we learned in algebra when we were dealing with quadratic functions, equations, they discussed the discriminant for us. Which is in the form of b squared minus 4ac. And if you're solving an equation, this plays a huge part. If it's positive, it gives you 2 real solutions. If it's 0, it gives you 1 real solution. If it's negative, it doesn't give you anything. When it comes to factoring, the only way you can factor a quadratic expression if this is a perfect square number, such as, I don't know, 1, okay, 4, 9, so on and so forth. So if you look at this case, again, I want to make sure you be sure that it can or cannot be factored. A is 1, B is negative 2, and C is positive 3. So B squared is negative 2 squared minus 4 times 1 times 3, which gives you 4 minus 12 is negative 8. So you need a perfect square number, okay, to be able to factor this. The reason I did that, for sure we know this cannot be factored and therefore nothing can simplify it further, okay? By the way, even if it can be factored, class, what really matters is having a common factor of x minus 1. So even if you could factor it, but there was no factor of x minus 1, it's no good. Okay, so that's a piece of information from algebra. All right, we want to do this, and if you recall in the previous section, anytime we have a square root or any type of a root for the sake of differentiation using the power rule, we change that accordingly. So in this case, square root of x can be changed to x to the power of 1/2. Okay, so that's the first thing we need to do. I'm going to put a raised dot in between, meaning I'm using the product rule. So f prime g plus g prime f. So if this is the f function, let's write it at top just to be on the safe side. So this is the f function, this is the g function, and therefore the derivative of f x to the power of 1/2 is 1/2 x to the power of 1/2 minus 1, which is negative 1/2. We've done this many times in the previous sections, okay? And times e to the power of x, so that's f prime of g, f prime times g. And then the g, the derivative g prime is itself e to the power of x times x to the power of 1/2. So that's what we get. Now, needless to say that we don't like negative exponents. Okay, this has a negative exponent. So x to the power of negative 1/2 goes down, becomes x to the power of positive 1/2. And remember, x to the power of positive 1/2 is what? Square root of x. So we are changing this, and we are using our algebraic techniques to go back, put it back in the proper format. Now, for the sake of other sections, we are interested in factoring this, and it becomes the following class, okay? I'm going to quickly show you how you do that. So one easy way is to come up with the LCD, and I hope you realize that 2 square root of x is the LCD, and the first part, okay, is that. Plus, here's the second part, everybody. So let me write, here's the second part. Remember, in order to come up with the answer, so let's write that e to the power of x, square root of x, and you have to multiply that by the denominator. Again, this is basic algebra. I hope everybody is comfortable with that. So this gives rise to the following: e to the power of x plus, now the product of these two is 2x. Okay. In the numerator, I can factor out e to the power of x. And I get 1 plus 2x as over 2 square root of x. And whether I write it in this format or in this format makes no difference. We will see later on why we need that. Many times we have to set this equal to 0 and solve, and all interesting things happen with the application. All right, so we did use the product rule in this example also. Let's look at this one. We need to use the quotient rule. Again, we're going to write it as f over g, which means we're taking the top function e to the power of x to be the f, and the bottom would be g, 1 plus x. So sticking with the quotient rule, the derivative of the top is itself, so that's f prime e to the power of x times the bottom, 1 plus x, minus the derivative of the bottom is simply 1 times the top, which is e to the power of x. So that's the top. What about the bottom? Just write it in a parenthesis and square it. You don't have to do anything, just that. Okay, class? So with that being the case, we are going to distribute. We get e to the power of x plus e to the power of x times x, okay, minus e to the power of x. Let's do that, and we notice these two cancel each other, and we are left with e to the power of x times x in the numerator. We bring the x in front. All right. I think it's pretty straightforward, class. Let's look at this example. We are going to use the quotient rule, and the f function is 1 plus sine x, and the g function is x plus cosine x. So what do? We are going to use f prime g minus g prime f over g squared. Okay, so 1 goes away, becomes 0. Sine gives you cosine x times the bottom, x plus cosine x, minus g prime. So the derivative of the bottom is 1, okay, plus the derivative of cosine is negative sine x. Okay, so 1 minus sine x times the top, 1 plus sine x. So that's the numerator. Over the g squared, just write the denominator, don't do anything, in a parentheses and square it. So let's just write, making sure everybody's comfortable with that. We have f prime g minus g prime f over g squared, and that's the end of calculus step. Let's go with trigonometric and algebraic steps. So first thing first I want to discuss, and I want to remind you, is the following, class. A minus b times a plus b, everybody remembers that, right? A squared minus b squared, which means this one becomes, simply put, 1 minus sine squared. We are going to distribute the cosine x times x, and then cosine x times cosine x. So this becomes x cosine x, that becomes cosine squared x. This negative sign remains, and this product changes to 1 minus sine squared. So next one, I want to remind you of the following trigonometric identity known as Pythagorean identity. Everybody, I hope, remembers that. Sine squared plus cosine squared equals 1. Okay. Therefore, we can say sine squared is 1 minus cosine squared. We can say cosine squared is 1 minus sine squared. Okay, there's nothing brand new, class, from the original one. Okay, from the one in the box, we can write this, and we can also write, for example, here sine x is plus minus the square root of 1 minus cosine squared, and over here we can write cosine x is plus minus the square root of 1 minus sine squared x, as an example. Okay, so having said that, this is cosine squared, everybody. So let's write that. Cosine squared and negative cosine squared, they cancel each other. So the numerator is just left with x cosine x, and we are done. So I hope you see, for an example like this, we had just one step of calculus. Look at this one. This is your only calculus step. And then what happened? Several steps followed that it involved algebraic techniques, trigonometric identities. So prior knowledge of mathematics, I can't emphasize the importance of that. So we use the quotient rule. The question is, do we have to use the quotient rule? You think we have to use the quotient rule, class? Well, you can use the quotient rule, but it is definitely not necessary. All you have to do, recognize this is t to the power of 1/2 and make up two fractions. When the denominator has one piece, I don't want to say one term because it's not a polynomial in the denominator. So you can cut them into two pieces as such, and then do the math. I hope you recognize the exponent here is 1, and we are going to use the exponential rule for quotients. A to the power of m over a to the power of n is a to the power of m minus n. So if I'm looking at this one, I get t to the power of 1 minus 1/3 minus, for this one is t to the power of 1/2 minus 1/3. Okay. Now 1 minus 1/3 is 2/3. 1/2 minus 1/3. You take a common denominator of 6 and it ends up being 1/6. I hope nobody has any problem with fractions. So with that being the case, what happens? We put the 2/3 in front. T to the power of 2/3 minus 1, which is negative 1/3, minus. We put the 1/6 in front. T to the power of 1/6 minus 1 is negative 5/6. So again, this one class, 2/3 minus 1, okay. This one, 1/6 minus 1. Negative exponent goes down, and it becomes positive, and you're done. Okay. So, do you have to use the quotient rule? No. Can you use it? Yes. Generally speaking, if you don't see the easy way out, it's going to be difficult to finish. All right. We have several trigonometric functions and their derivative. We said the derivative of tangent is secant squared, and we are going to quickly look at the proof of that, okay? And you can mimic that to prove others. For example, for cotangent is negative cosecant squared. So let's see how we do that. Everybody remembers tan is sine over cos. So again, let's write a couple of formulas. Cotangent x is 1 over tan x, also cosine x over sine x. Okay. Secant x, 1 over cosine x, cosecant x, 1 over sine x. These are some of the formulas in trigonometry, just to refresh your memory. So we are going to use the quotient rule as follows. The derivative of the top, okay, is cosine times the bottom, cosine. So this is f, class, this is f over g. And minus the derivative of the bottom, cosine gives us negative sine times sine over the bottom squared. So take a look. We get f prime g minus g prime f over g squared. We're practically done because the numerator class is cosine squared plus sine squared. And we know that to be 1. Cosine squared plus sine squared is 1. And the final answer is secant squared. Believe it or not, this is the proof.